Okay, so next let's go to the actual configuration of inspect type parameter maps, and also of port to application mappings, and also of out of order parameter maps. So first let's look at the defaults on router 1. So if we say show policy, let's look at those two commands: show parameter map, type inspect. And we can say there's also a global one. It's not a discussion, it's pretty much a more advanced topic. So let's look at the default one, so we have a default parameter map. We can verify it with this command or with show policy firewall. Show policy firewall. Config parameter map default. So this default parameter map of type inspect named default, it has audit trail off. It has alert on. So it is going to alert me, it's going to send me a log message, as we saw before, if something suspicious is detected. Like as we saw previously in here. Not debugging, but somewhere before, let me get back to that specific log message. There you go, this one. There was something suspicious in a TCP packet. This one. It says error straight retransmitted segment. So the firewall has saw the same packet multiple times. So it looked like a suspicious activity, it looked like an attack, right? That happened, so the alert works by default. That happened when I telnetted from router 3 to PCA, and PCA was not available. Which means router 3 was constantly resending the SYN messages, the same SYN message. And that looks suspicious from the router's point of view. So we saw that message, and that was a alert, pretty much. So by default, alert is on, but audit trail is off. We're going to enable that. Then we have some default setting which states that the router is going to drop. It's going to remove a UDP session from the state table if it was idle for 30 seconds. It's going to remove an ICMP session from a state table if it was idle for 10 seconds. It's going to remove a DNS session from a state table which if it was idle for 5 seconds. Of course, this means that match protocol DNS is required. So the router knows that that's not a DNS, a regular UDP session, but a DNS session. So as you can see, even though DNS runs over UDP, an idle DNS session is going to be closed faster than a regular UDP session. That is because it's a lot of attacks that can happen through DNS, and we want to close the gate as soon as possible. Because what happens is PCA sends a DNS request out on the internet to whatever the DNS server is, let's say. A DNS query to its server. The DNS server replies. DNS reply. And then a session becomes idle. So router 1 is going to keep that session in the state table for 5 more seconds if there is no more traffic going on back and forth. Because it's dangerous to keep it in there, because somebody could potentially from the internet, let's say that the DNS query went out to a server of 1111. So somebody from the internet, because they know like what is my company public DNS server which I'm using, somebody from the internet could spoof that 1111 address. An attacker could send a spoof message from 1111 back to PCA with a source of 111, spoofing the DNS server of Advis. And he's going to get in because the session is in the state table of router 1. So as long as he spoofs correctly the source and the destination, he's going to get in. And to spoof the destination is very easy, because usually I get net as I go to the internet. So it's going to always know that traffic is going to be sourced, that DNS traffic sourced from the LAN is going to show up on the internet with a source of the netted traffic, which is this interface, with a source of what I net into 136.1.31.1, and a destination of my DNS server, which was 1111. So the DNS session, the PCA, its request was replied back by the server successfully. And now the entry is still valid in the state table of router 1, which means an attacker from here from the internet could quickly send a DNS packet sourced from 111, spoofing the DNS server Advis, destined to that netted Advis of the PC. And that packet is going to get in by the router in there. So that he could initiate an attack just by making use of the fact that UDP is connectionless. And it's a lot of attacks based on DNS. So that's why by default, DNS, an idle DNS session is going to be closed faster than a regular UDP session. Of course, for that to happen, you have to have match protocol DNS. So that when that session was built by the router, it had to match on a class with match protocol DNS. The router has to know that's DNS traffic. Likewise, we have TCP idle time to be 1 hour. So, and this makes sense because this is easier. This is more difficult to, let's say, spoof, because you also have to spoof the sequence numbers in there. So idle TCP session is going to be closed in 1 hour. Fin wait time is 5 seconds. So the router waits for to see the FINAC for 5 seconds. If it doesn't see it, it's going to close the session. It's going to kill the session and remove it from the state table. Likewise, the router waits for 30 seconds for the three handshake to be built. If it's not built, he's going to remove the SYN entry from the state table. This controls the total amount of sessions that are going to be sent to the firewall, which of course is a huge number. You may want to reconfigure this clearly. This controls the total number of embryonic session per host, of which is again a huge number. The router by default allows that big number of embryonic sessions per host. And block time means that if an attacker builds that amount of embryonic sessions, for how long is it going to be blocked? By default is 0. Of course, you have to tune this if you so choose to. It's not going to be blocked at all. And then we have the total number of embryonic sessions that a firewall allows in its state table. And by default, the low value and the high value are the same. If you would change this, that a high value is going to be, let's say, 100 sessions, 100 embryonic sessions, and low value to be 60. It means that when the router sees in its state table 100 embryonic sessions, the high limit, the upper limit, is gonna start removing sessions, embryonic sessions from the state table, till it's gonna reach the lower value. So with this configuration, if the firewall sees in its table 100 embryonic sessions, it's gonna kill 40 of them, actually 41, till it's gonna reach 60. And also we have the show parameter map, show policy firewall. Type in show policy firewall config parameter map, not this one. So for the O parameter map, you still have to use the old command show parameter map, type inspect parameter map, type inspect OOO global. Not type inspect, but type OOO global. So this is the TCP normalized settings. It's gonna be able to reassemble. Is gonna with the default settings. The firewall can keep in the queue up to 16 packets, or maximum 1024 memory consumption to reassemble a TCP stream, and that should take no longer than 5 seconds. And alarm is off, which means it's not going to send you an alarm if those values are exceeded. It's just going to kill the session. So now let's take one of our policies, show run policy map, one of them. So as I stated, if you look at any of those policy maps, let's take this one, pmap LAN to internet. All inspect actions, actually by default, they have the default inspect parameter map type applied. It's like inspect default, because at the inspect action you apply a type inspect parameter map to tell the router what are the advanced settings for inspecting traffic matched by that class map. And because you don't put anything by default, they put in there the default type inspect parameter map. Which means if we say show policy firewall config zone pair, let's say ZP LAN to internet, one of my zone pairs. If you look in the configuration in here, for the ICMP class, and this is something which is not correct, because it looks like for the ICMP class map, where I have the action of pass log, we have the default parameter map applied, which is not correct. Let me show you another command. So this is the wrong output. Let me say show policy firewall stats zone pair ZP LAN to internet. ZP. Before I do this, to confirm that's not a correct output. So it looks like the default parameter map, it's also applied to a pass action. If you say show run policy map, and you take any of those policy maps, and we go under the ICMP class, which has a pass log option. If you say pass question mark, you don't see in there that the default parameter map is applied as expected. That's what I said, that this output in here looks to be a cosmetic bug, because at a pass action there is no parameter map applied, only to inspect actions. So hopefully this command should give it a proper output. Show, not config, stats. Let me see if I say show policy map. Let's look at the old command. Show policy map type inspect. Yeah, I'm not gonna spend time in here. So this output in here is not correct. It is for sure a cosmetic bug, this one. Because as we saw and as we stated, and it makes sense, the inspect parameter map can only be applied to inspect actions, not to pass actions. And as we saw, even configuration wise, it doesn't show up. So this can happen. It's called a cosmetic bug. the output doesn't properly, actually doesn't really tell you what is the actual configuration. Either way, so to all of our inspect actions, we have that default parameter map applied. Which means if for whatever reason we're not happy with that configuration, with this one, we can create our own one, and let's go in there and say I'm gonna choose to, in my case, show parameter map, type inspect. I'm gonna build a parameter map for which the only thing I want primarily is that as traffic flows in this direction, which means from the LAN to the internet, I want audit trails to be on, audit trail to be on, and I'm going to change the default maximum number of sessions, so max sessions that can go to the firewall in that direction for that type of traffic to be, let's say, or not max session, let's change what else, because that's a global configuration. Let's not change the max sessions, but let's change the ICMP idle timeout. So let's look out at our LAN to internet policy map, show run policy map, LAN to internet. This is our policy map, LAN to internet. And TCP UDP traffic matches an inspect action, but ICMP traffic matches a pass action. If I want to be able to say that ICMP traffic idle timeout is going to be 5 seconds or 2 seconds, I have to change that action to be a inspect action. That's the first step. I want to say no pass log, and I'm going to say inspect. Let's confirm that. Then as I go LAN to internet, I'm inspecting TCP UDP, and I'm also inspecting ICMP. So let's build two parameter maps. Parameter map, type inspect, as let's name it LAN to internet for TCP and UDP. Now I'm going to say audit trail on. That's the only thing I want for TCP UDP packets. And the parameter map type inspect LAN to internet for ICMP. I'm going to say ICMP idle time to be, let's say, let's put it higher, not slower, just to see it in the connection. Let's put it, let's say, 100 seconds. Or let's say 2 minutes, 120. So I've configured the parameter maps. If we now say show parameter map, type inspect, this one, LAN internet ICMP. As you can see, I only changed the ICMP idle timeout, and everything else which I have not configured is inherited from that default parameter type inspect. While if we verify the other one, and of course, as you can see for this ICMP parameter map, audit trail is off. Let's also enable audit trail for both ICMP and TCP UDP, conf T, audit trail as well, audit trail on. So now looking in that parameter map for the ICMP traffic, we have audit trail on. We change the default idle timeout for ICMP to 120 seconds, and everything else is inherited from the default parameter map of type inspect. If we look on the other one, LAN internet TCP UDP, we just changed audit trail to be on. Everything else is left at default. I guess you can see the ICMP idle timeout is left at default. So now if we say show run section parameter map, and we say show run policy map, show run section policy map policy map pmap LAN to internet, policy map type inspect, of course. We want to go and state for the TCP/UDP traffic. I want to inspect traffic, so it creates entry in the state table. But advanced inspections are going to be done as configured in this parameter map. And for ICMP, likewise I want to inspect, but advanced inspection performed as matched in this parameter map. Inspect and that. So if we look again at our policy map, then there we go. For TCP traffic, I'm inspecting it, and advanced inspections performed at that parameter map states. For ICMP traffic, I'm inspecting that traffic, and advanced inspections are performed as that parameter map states. So first, let's ping from PCA to router 3, which means we should see an alert going on, and we should see that the idle timer is going to be 120 seconds in there. So it's not going to go away from the state table that fast. Let's go on PCA. And let's ping router 3. There we go. We see audit trail which says start ICMP session. It started. I'm going to see another log message when it ended, which means after 120 seconds, because that's the configured idle timeout now. So if we say show policy firewall, so this states that I match on that zone pair with ICMP traffic, and I started the session from PCA to router 3. If we say show policy firewall session zone pair, and let's put in here ZP LAN to internet, we see the ICMP session which is going to stay in there for 120 seconds. Last heard 47 seconds ago. So when it's going to be deleted in 120 seconds of being idle, I'm going to generate a new log message. You're going to see how that looks like. Let's also now telnet from PCA to router 3. I'm going to match the other inspection, the other configured parameter map of type inspect. On PCA, let's telnet 5553 CISCO. Session was created. I should see a log message. There we go. It says what is the target, which means what is the zone pair and in which class map do I match. That's my zone pair and traffic match on this class map as expected. TCP session was started. Now if we kill it, exit, the file is gonna see the finx, which is gonna remove the session from the state table. And there we go, it generated another log message saying that session of TCP/UDP now has been stopped, and we got that amount of bytes sent by the sender and received by the responder to that session. And now because also 2 minutes later the ICMP session is being deleted from the state table because of the idle timeout, I stopped, so that has been stopped, which means I removed the session from the state table, and we send 128 bytes both ways. Echo request 128 bytes, echo replies 128 bytes. And if we look now in the file state table, we should see nothing in there for that zone pair. LAN to internet. And there we go. Nothing in there. Okay, now let's speak about PAM. So now if we remember about the firewall policy, which was LAN to WAN, I had a policy in that direction where I was inspecting FTP. Inspect FTP. Let's confirm that on router 1. Show run policy map. So the one which was LAN to WAN, and is this one. LAN to WAN and I matched on that class map. I said inspect, and in that class map, actually, I'm matching on protocol FTP. Show run class map. I'm matching on protocol FTP. So how does the router know what is that protocol actually? Because it's going to perform application layer inspection. It's going to look at the application layer. But like layer 3, layer 4, what is the TCP or UDP port number that is being used? Show IP port map, FTP. And the default mapping for FTP is on TCP port 21 as expected, and is system defined. So let me put this configuration in Notepad again in here. For LAN to WAN. And let's change this default class, default configuration to a drop log for the moment. Now what's going to happen is that if this server, the FTP server, actually listens on TCP port 2121, not the default one, or whatever other port, doesn't matter. When I'm going to try and connect from PCA to server A on destination TCP port 2121 on the control plane session, this is going to be dropped because this configuration in here states that, and of course let me put the zone pair as well, which is LAN to WAN. There we go. So what's going to happen is I'm going to send a packet source from PCA, TCP source random, destined to PCB to server A, TCP destination being 2121. And this session goes in the direction source LAN destination WAN, which means I copied in here the wrong source LAN destination WAN. There we go. This one. And that session is going to go in the direction source LAN destination WAN. So it's a TCP packet on destination port 2121. And the router says, okay, traffic goes that way. What is my firewall policy? My firewall policy is defined by this policy map. What does my policy map states? It's going to process it top down. It's going to say, do I match with that TCP session on port 2121 on which of my class maps? Do I match on this class map? This class map states match FTP, which by default what that means, it means TCP port 21. So it's not going to match on that class map of type inspect cmap TCP, which means it's going to match on the default class map, and it's going to drop the packet and send a log message. Let's confirm that. So let's make the FTP server run on port 2121. Listen on port 2121. Okay. Let's make sure that I'm listening on port 2121. Netstat -i find netstat. And I am listening. Okay. So let's go from PCA and connect, try to connect to port 2121 to confirm I'm going to be dropped because I'm going to match on the class default. PCA. Let's reopen FileZilla, and I'm going to say CISCO on port 2121 and try quick connect. Abort previous connection and connect in a new one in current tab. Okay. If we look in the firewall, there we go. It says that a session was initiated from PCA destined to server A on port 2121 that match the zone pair LAN to WAN, but I match on a class default with a drop action. So if I want to fix this, because my server runs in active mode, which means I need to inspect FTP, I have to make sure that match protocol FTP from Navarro's point of view means also TCP port 2121, which by default, which by default show IP port map FTP, it means only port 21. So I'm going to say conft IP port map FTP port TCP 2121. If I say show IP port map FTP now, the router knows that FTP is going to be both traffic destined to TCP 2121, that is a system defined HV, and traffic destined to TCP port 21. So traffic destined to port TCP 21 is this system defined, and traffic destined to TCP port 2121 it's user defined. I have defined that. And of course, if I'm running FTP on port only 2121, I can even kill the system defined one. But anyway, now it is going to work, because now I'm going to match on protocol FTP with my session on port 2121, because port to application mapping knows that FTP is TCP port 21 and TCP port 2121. So now if we connect again, if we say quick connect, it should work. And I got connected because I seen here the remote side directory, and if you look in the Firewall state table, we see no log message. It said command issued before session is authenticated. That's not a kind of, let's say, alert, but the session was not dropped, which means show policy firewall session zone pair ZP LAN to WAN. I should see the control plane session being built, and there we go. We see it from PCA to server A on port 2121, and that's FTP traffic.